Hey there, year 8. So for exercise 3C, we're working on fractions again, add, subtract, multiply, divide, except this time we're going to have negative numbers. So it just means you have to remember stuff from chapter 1 with integers again. So I put a number line there just to help those to visualize the negative numbers again. But remember from chapter 1, the negative means the reverse or the opposite direction. I usually like to think it's just removing debt. Okay, so if you're minusing a negative value, that's like saying removing debt, which is a good thing. If you're removing debt, you've gained. Okay, so try to remember that, what I taught in class about that concept. But here we go, let's practice adding, subtracting with negative fractions. It's exactly the same concept as 3b. 3b was about adding fractions. Now remember, when you add fractions, they have to be the same type of fraction. In this scenario, they're both 1/7 type. Okay, so that means in a pizza, I'm going to cut it into 7 pieces. So 1, 2, 3, 4, 5, 6, 7 there. So 1, 2, 3, 4, 5, 6, 7. So one of these pieces is considered 1/7. Okay, so that's the type of piece I have. Now, how many of these pieces do I have? I've got -6 of those. Okay, so I've got -6 of these, -6 of those, and then I've also got another 2 of those 1/7 pieces. Okay, so when we add them, remember, we just need to make sure that they're the same pieces, and because they are the same type of fractions or pieces, we can say, oh yeah, well, they're all 7s. I have, though, -6 plus 2 of those 7s. So how many of these 7s do I have? And so this goes back to your number line again, -6. Where is -6? So think about it. This is 0. -6 is on the left. And this is where -6 is. And then what am I doing? I'm adding. So which direction am I going? I'm going to the right. By how many units? I'm going by 2 units. So it's 1, 2. And because you're going to the right by 2, remember the numbers actually, the closer you are to 0, it actually reduces to -5 to then -4. So then the answer here would then be -4/7. Okay, so the nice thing about adding these fractions was that the denominators were the same, so you didn't actually have to do anything to change it. You just needed to remember how to add negative values. Okay, now let's try example 2 now. See, example 2, it's different. This one has a denominator of 3, so in a pizza, I'm cutting the pieces, so 1 piece, and then 2, and then 3. Clearly, each piece now is a lot bigger than this one before, right? So this is 1/3. Whereas the other one, this is fifths, okay? So these are in terms of fifths. And if it's in fifths, if you think about a pizza, I'm cutting it into 1, 2, 3, 4, and then 5. They're not even there, but you can see the pieces are very different. And because they're different, you can't count the number of slices the same way. So one of the first things you have to do is to make it the same slices. And this is where you use equivalent fractions, where you look at the multiples of 3. So you can write 1/3, the same thing. If I doubled the denominator, double 3 gives me 6. That means I double the top, it gives me 2. So that's now 2/6. But if I tripled the denominator instead, that would have been 9. And then I have to triple the top, which makes it 3. And then I quadruple the top, which is 4, and quadruple the bottom, that becomes 12. So all of those are equal to 1/3. What I'm looking for is which one of those type of fractions will have the same denominator as 5. Okay, or equals to 1/5. And hopefully you picked up here that they both share a common multiple of 15. Because if you think about it here, 1/5, if I double it, that becomes now 2/10. If I tripled the 5, there would have been 15. And then triple of 1 is 3 on the top. And then if I had carried on to quadruple, it would have been 4/20, right? But can you see, had I just gone a bit more for the thirds, if I had times it by 5, I would have had 15 as well, and then times the top by 5, and I would have had 5/15. So that is equivalent to 1/3, and this is equivalent to 1/5, but the difference is that they both share the same denominator now. So what I'm saying is, instead of writing -1/3 minus 2/5, I'm changing that to now -5/3. 5 on 15 because that is the same thing as a third. And then I'm subtracting and I'm changing the 2/5 to 3/15. Okay. Oh, sorry. I just realized there was a mistake here because that's 2/5. So I got to double. All right. Just to be clear with what I'm doing, I'm just going to show you again. To make 3/15, I'd have to times 3 by 5, times this by 5. That's how I get -5 on 15. Minus, and then I have to times the bottom 5 by 3. Then that means I have to times the top by 3 to then make it 15 in the denominator, but that means it's 6/15. Okay, now they're both 15ths. I've got -5 minus 6. Okay, so again, use a number line if it helps you. But -5 is like you owe $5, and -6 means that's another $6 that you owe. So together, how much do you owe? You owe $11. Or another way of thinking about it is like minus means you spend. So you spent $5 and then you spent $6. So in total, you're still losing money. So you lost an overall of $11 because you spent $11. Okay, that's another way of thinking about negative numbers if that was tricky for you in term 1. And then we're moving on to example 3 here. Example 3 now puts in a bit of a mixed fraction with mixed denominators there. And same thing, in order to add or subtract fractions, especially with mixed fractions, change it to improper first. So to change this mixed fraction to improper, remember you times the denominator to the whole number, and then you add to the numerator. So let's rewrite the equation. You've got -8 on 3. You've got a minus sign. And now in the brackets, 5 times 1 is 5, and 5 plus 1 is 6. So it's 6/5. But don't forget, it's a -6/5. Okay? I think a lot of students also make a mistake of timesing 5 to the -1. No, it isn't. Remember, this fraction is a number, and that's the sign. That's just telling you it's a negative of that value. So that's why we don't really worry about the negative. We just do 5 times 1 and then plus 1. Okay? So times and then add. All right, so now that we've got them here, again, remember they are different denominators. And because they're different denominators, we have to make sure they are the same before we can even add them. So here we're going to go -8 on 3. This is, remember, if you're subtracting a negative, that's like saying, remember, that's like saying removing debt. If you're removing debt, so if you owed $6/5, okay, if you owed $6/5, that's how much you owe. But then I'm saying, let's remove that. Well, then now you don't owe $6/5, you've gained 6/5. Okay, so that helps to simplify the problem a bit. So minus a negative means removing debt. So it's like you gaining, and that changes it. If you're gaining, it's an add. Okay, you're not losing. And now, in order to add these fractions, remember the denominators have to be the same. So I know common multiple was 15 before, so 3 times 5 will give you the 15 you want. But whatever you do to the bottom, you must do to the top. So then that gives you -40 plus, and same thing, to get 15 in the denominator, 5 has to times 3, and then you got to times 3 to the top to keep it equivalent. And here we get 18 on 15, and then putting it together, now they're all out of 15. So it's -40 plus 18. So think about it, you owe or you've spent $40, and then you earned $18. Okay, so you spent 40 and you earned 18. So how much are you still in loss? Okay, think of it that way. Or again, if you draw a number line, you can see -40 is on the left, so -40 is over here, and then you're plussing. So plussing goes back to the right, and you're going back 18 units. So 40 going back 18 is the same thing as saying 40 subtract 18. But remember, you're going to be on the negative side. So the answer, no matter what the answer is, it's going to be a negative answer. Okay? And it's just what's 40 take away 18? How far have you gone back to? And hopefully you're able to work that out. That would then be 22. Okay, so -22 is where you would be sitting at. So here we write -22 on 15, and if you like, you can also convert it to mixed fraction. You can say how many 15s fit into 22. It fits in once, remainder 7 on 15. Okay? So those are your 3 typical examples of this exercise. So you just work through both negative numbers and you're also applying what you learned previously. So those who struggled adding, subtracting in the last exercise, you may need to brush up on that before working with negative numbers. Okay. So here's a couple of practice questions for you to try first before you do any other questions. You can pause the video here because the next part of the video, I'm going to show you how to multiply and divide. So here we go. Assuming that you have already done practice of add and subtract, I'm now going to do a couple of examples of multiplying and dividing. Another thing to remember from multiplying negatives in chapter 1, remember double positive is positive, double negative is positive. So if they're the same signs, they're both positive. If they're different signs, then they're negative. Okay? All right, here we go. Nice thing about multiplying fractions is you just got to do top with top, bottom with bottom. But remember, I always said try to see if you can find a way to simplify. Check a top number and then check a bottom number. Are there any pairs that have a common factor? And based on what I'm saying, 3 has no common factors of 5 and 2. So nothing for 3. And then 1 has no other common factors 5 and 2 besides 1 in itself. So that's as small as it can go. So we just do 3 times 1 on the top. Actually, there's a negative there, actually. I didn't see. So it's a negative. So negative 1. And then 5 times 2 on the bottom. And that gives you negative 3 on 10. Now, sometimes students get confused. Negative at the front of half. That is actually, it doesn't matter where the negative sign is. It could be negative 1 on 2, or it's the same thing as saying 1 on negative 2. Okay, and the reason being is because one is positive and the other one's negative. So the overall answer, if you have a plus negative, the overall answer is going to be a negative. So that's why it doesn't actually matter. I like to put in the numerator because the denominator gets confusing if you leave a negative there. So that's why I generally personally like to put the negative in the numerator. And that's why I did 3 times negative 1 rather than 5 times negative 2. Okay, if that was something that you were wondering. All right, so that was example 4. Example 5, again, you can do 5 times 18, 9 times 20, but notice the numbers would be pretty large there, and sometimes it has to be that large, but in this case, we always check if there's a top number and a bottom number that you can simplify. And yes, you can. There's a 5 and a 20 that I can see. So 5 and 20, what do they share as a common factor? They both share factor of 5. So 5 goes into 5 here, goes in once. So that means you get 1 over 9. And don't forget there's a negative there, so negative. Times, and there's a negative again, 18 on. Now, how many 5s did fit into 20? 4 times. Okay, so I've reduced the 5 and 20 to become 1 and 4. But then I also notice another one, 18 and 9, they share a common factor of 9. So that means 9 can go into 9 once, 9 can go into 18 twice, and that changes your fraction to negative 1 on 1 times negative 2 on 4. Now, before you even multiply, notice now I can still simplify even further. Have you noticed that the 2 and the 4, see, always a top number and a bottom number. Okay, 1 top, 1 bottom. Okay, you can't do 2 tops and can't do 2 bottoms. It has to be 1 top, 1 bottom. Here we can see that they both share a common factor of 2. And so now I've reduced the fraction to negative 1 on 1 times negative 1 on 2. And that's as simplified as you can get. So now we can do top with top when you multiply, and then bottom with bottom. So negative 1 times negative 1. Remember, double negatives become positive 1. Whereas the denominator, 1 times 2, is just 2. So your answer is positive half. Okay, so that could get tricky for some people, especially with the negatives and then factorizing and simplifying. Here, the only trick there is that there's just 3 of them to multiply, but same concept. Now notice here, negative times a negative, double negatives make a positive. So whatever these 2 answers multiplied to is going to be a positive. But then you're going to take this positive and you're going to multiply to a negative number, so negative half. So positive and negative actually gives you a negative fraction. So the overall answer at the moment, I know it's going to be a negative. Okay. Now, when we multiply them, we multiply top with top and then bottom with bottom. So it's pretty nice and easy in this case. 1 times 1 times 1 is just 1 on the top. And then 2 times 2, which is 4. 4 times 2 is 8. So your answer is negative 1/8. Okay? So I like to work out the signs later on. I do the numbers first and then work out the signs later. Okay? Or you could have done it slowly as well. You could have done negative 1 times negative 1 and then times negative 1 again. And then you would have got the same answers I would have. So whichever way you prefer. Division. So reminder, division, you guys told me that you learned from last year. KFC method, keep the first, flip the second, and change the sign. Okay? So here we keep the first, flip the second, and change the sign. So now we've went from division to multiplication, and we check if there's anything we can simplify. No, I can't find a top number or a bottom number that has a common factor. So now top with top, bottom with bottom. So negative 1 times 9, and then 4 times 5 in the denominator. What does that work out to be? Negative 1 times 9. See, 1's negative, 1's positive. So overall it's going to be a negative, so negative 9. And then 4 times 5 is 20. Okay. Here's your last example for this video. You can see here, a lot of students tend to feel like this is a bit confusing, so they usually flip the first one. No, you don't ever flip the first one. Remember KFC, you keep the first, so it's negative 3/5. You flip the second. Now, what is 4 as a fraction? 4 wholes is 4 over 1. Because when we say wholes, it's 1 unit, 1 whole. So you got 4 of them. So that's why this represents 1 whole. This represents 1/5, right? So you got 4 of those wholes. So 4 over 1, if you do the flip, it becomes 1 over 4. The division sign becomes times, and then you're back to what you're familiar with top, bottom with bottom. If there aren't any other numbers you can simplify, which I don't see. So no top number, no bottom number has a common factor. So really just working out what negative 3 times 1 is, and then what 5 times 4 is. That gives you now negative 3 over 20. All right, team, I'm going to leave the last two for you to think about what the power of 4 is. For those who don't remember what those indices or powers mean, when you put a power of 4 there, it just means multiply itself 4 times. So in this case, it's actually saying negative half times negative half. That's twice. That's 3 times. Whoops. 3 times and then 4 times. That's what the power means. Okay, so here, this is different. This is now saying you're going to do the negative of 1/3 times 1/3 times 1/3 times 1/3. There's a subtle difference between the two. Okay, so one, it's inside the bracket, the negative is inside the brackets, and the other one, negative, is outside. A lot of students confuse the two, and that's why they get that wrong. Okay, so it's BODMAS. Anyways, whoops, that should be half there. All right, I'm going to stop there, and good luck. I'll see you in the next session.